Now I'm going to answer the questions about test 4, the mostly incorrect answered questions. I'm going to answer them. The first question is question number 16. Almost 50% incorrectly answered question. So question number 16. So this is the question number 16. Which of the following is correct for 2 points A and B for a merry-go-round rotating about a fixed axis as in the figure? So merry-go-round is a rigid object, so we should first know this. And we know that for a rigid object, every single point on the rigid object will have the same angular displacement, same angular speed, same angular acceleration, and the rotational quantities are the same for all the points. When I check the answers, which is done incorrect, is A. A is 24% of the students answered A. So they know half of the question's answer. So because it's a rigid object, angular speed of A must be equal to angular speed of B. This is correct. But if a question has such a choice that both A and C, both B and D, you should check both choices. Yani A is correct, but A is only correct answer. So let's check B. B says point A has angular speed twice of point B. This is incorrect because we know angular speeds are equal. But we know that tangential speeds are different for different points at different distances. So point A is on the outside, point B is inside. So that's why point A is faster than point B. So choice C talks about the tangential speed. But it says that point A has twice the tangential speed of point B. Is it twice or not? So there is a note. Note that point A is twice as far from the center as point B. And if you say radius of the circle followed by point B is R, so radius of the circle followed for point B is going to be twice of that. And because tangential speed is directly proportional by the radius, if the radius is doubled, so if R changes to R, because omega constant for both points, V changes to 2. So that's why point A will have a tangential speed twice of point B. So C is also correct. Then both A and C, choice D is going to be the correct answer for this question. Next question, which is mostly incorrect answer, is 27, which is one of the ministry question of 2022. It's again about this shape, this picture. Which of the following is correct for 2 points A and B for a merry-go-round rotating about a fixed axis as in the figure? So this merry-go-round, again, rigid object, and we know that for a rigid object, every single point on the object will have the same angular speed. That's why choice A is correct answer. Choice B says that angular speed of A is greater than B. This is incorrect because all the points have the same angular speeds. Choice C says that tangential speed of B is greater than A, vice versa, because the one which is outside is faster. Choice D says that tangential speeds are equal, not possible. Only tangential speeds can be equal for 2 points at the same distances. And if a point is in here, the other point is in here, they can have equal magnitude of tangential speeds, but point A and B are at different distances, so that's why they cannot have equal tangential speeds. Next question is question number 7. Question number 7 is about definition. The time rate of change of instantaneous speed in tangential direction of the circular motion is called what? So when I check that, I see that 8% of the students give the answer D. Yani they said centripetal acceleration. Yes, it's a circular motion, but circular motion is a centripetal acceleration. It's obviously correct. But This definition is not about the change in direction. So centripetal acceleration is about the change in direction. This must be defined as the time rate of change of variation of the direction of velocity. So, but this definition is not talking about the direction. It says that just the change in instantaneous speed and speeding up or slowing down. So if it is just about speeding up or slowing down, it's going in a circular path and linear speed. So it must be tangential acceleration. Next question, question number 6. It's about, again, a carousel. The points A and B represent two horses on a carousel. So as you see, they are at different distances. Which of the following is correct? Because this carousel is a rigid object, we know that every rotational quantity for every single point is going to be the same. So angular displacement, so it's a rotational quantity of horses are equal, correct. But we are looking for wrong answer. So this cannot be answered for this question. The distance traveled by the horses are equal. So we know that arc length, which is distance traveled by horses, called arc length. Outside horse travels a longer distance than inside horse. So their distance traveled by horses cannot be equal at equal times. So then this is incorrect. And we are looking for a wrong answer, so this is the correct one. So for this choice is the choice of that question. C says the tangential speed of horse B is greater than horse A. Yes, outside horse is faster than inside horse. This is also correct statement, but we are looking for wrong statement. The angular speeds of both horses are equal. Yes, angular quantities are the same for a rigid object. So this is also correct statement, but we are looking for wrong statement. Wrong statement is B. And 8, question number 8, it is this one. What is the tire's angular acceleration? So questions about alpha in a radian per second square if the tangential acceleration at a point of radius 15 centimeter is 9.4 times 10 to the power negative 2 meter per second square. This is the AT. How do I know? Meter per second square. Radius is given 15 centimeter, we should convert it to meters, 0.15. So we know that AT is equal to R times alpha. AT is given 9.4 times 10 to the power of negative 2. R is 0.15 meters multiplied by alpha. So we have to divide by 0.15. We have to divide by 0.15. So they will simplify. We will get the answer as 9.4 times 10 to the power of negative 2 divided by 0.15. Answer is 0.63. So B is the correct answer. Alpha is 0.63 radians per second squared. So what is the answer given correctly in here is this. The choice D, 74% correct, incorrect answer. Choice D is 0.014. How do you get choice D? Because you don't write the equation. By multiplying this and that number, you calculate choice D. And if you multiply R by AT, you can get alpha. But this is not the equation which we are talking about. So our equation is AT is equal to R times alpha. Not alpha is equal to R times AT. So you should be careful about the equations. First you should write the equations, then continue with the problem solution. Next one is question number 10. Question number 10. If an object has a tangential acceleration of negative 10 meters per second square, the angular speed will do which of the following? If acceleration can be tangential acceleration or angular acceleration, if it is negative, object is slowing down. So here is just negative 10. Slowing down. What does slowing down mean? Angular speed decreases, tangential speed decreases. Both are decreases. So B is going to be the correct answer. After 10, it is 13. Two horses attached to a carousel at different distances. If the horses are different distances, they follow different circles. So radiuses are different. Have same angular speed. This is correct because for a carousel which is rigid, every single point will have the same angular speed. The same angular acceleration, correct, because all rotational quantities are the same. Same tangential speed? No, tangential speed at different distances are different. Let's say. So both A and B are correct answer in here. After 13 is 14. A child on a merry-go-round undergoes 1.5 meters per second square linear acceleration. It even says linear acceleration, it is tangential acceleration, AT. If the merry-go-round's angular acceleration is 1 radian per second square, which is alpha is 1 radian per second, how far is the child from the axis of rotation? Calculate the radius of the circle. So AT is equal to R times alpha. This is the equation. AT is 1.5. R is the question. Alpha is 1. So just 1.5. R is equal to 1.5 meters. So what is the incorrect answer given in this question 14? Is B, most probably. How they get 0.67? They divided 1 radian per second by 1.5, most probably. So because you don't write the equation first, and without equation you try to answer the questions, so you incorrectly answer the questions. After the 14, it's 5. Question number 5. The radius of a seed in the computer is 0.05 meters, which is R. Micropride on the disk stream has a tangential speed AT. Calculate the disk angular speed, which is omega. So again, most probably this problem, if done incorrectly, you didn't write the equation. So this is not AT, sort of VT, tangential speed. So VT is given. So I will write the VT equation. VT is equal to R times omega. VT is 2. R is 0.05. Omega. So simplify by 0.05. Simplify by 0.05. Omega is going to be 20 divided by 2 divided by 0.05, which is 40. 40 radian per second. So it is correct answer. And the last question is 9. Question number 9. So it is this one. 4 points A and B at different distances, again different distances, from the axis of rotation, and the radiuses are different. Which of the following quantities are equal if the rotation is rigid? So in fact, it says that all rotational quantities are the same. Angular speed, angular acceleration, angular displacement. But linear quantities, which are tangential speed, tangential acceleration, arc length, they are different. So which are equal and same for all similar is the angular speed. So this is all about test 4. So I will continue with test 5 and 6. But first, student must answer the questions because the less number of questions are answered. So if you want to contribute this video, so you have to do those tests as quick as possible.